In this lesson, we are going to look at sketching graphs of polynomials. So our goal, and this is going to be a 2-day lesson, so this is going to be day 1. Our goal is going to be identify graphs of polynomials using end behavior and multiplicity of zeros. So today, we are going to look at polynomials, multiplied all the way out. Tomorrow, we'll look at factored form of polynomials. So in example 1, we are going to identify graphs using end behavior. Directions: use the degree and leading coefficient of the polynomial to determine the end behavior of the graph. Find the graph that matches the polynomial function. So whenever we're looking at polynomials, first thing you always want to make sure it's in standard form. Your degree is the highest power in your polynomial, and then your leading coefficient is the number in front of your first term when it's in standard form. So for A, I have f of x equals 2x to the third minus 12x squared minus 6x. This is in standard form. It's going from highest power to lowest power. Starting with my degree here is 3. Okay, so that degree equals 3. And then my leading coefficient, and I'm going to abbreviate this, leading co is 2. Now, looking at my degree is 3. That is an odd number. And my leading coefficient is 2. That is a positive number. So for odd positive, we need to think about our end behaviors. The first arrow is going to go down. Second arrow is going to go up. So I need to find a graph where on the left we're going down, on the right we are going up. So for the first graph, we're going up, then down, so no good. Second graph, we're going down and down, so that one doesn't match. The third one, we're going down, then up, which is what we want. The last one, both of them are going up. So the answer is going to be this third graph. So now we're going to go ahead and look at B. For B, I have negative 2x to the fourth minus 20x plus 35. Here, my polynomial is already in standard form, so I can go ahead and identify my degree and my leading coefficient. Again, my degree is my highest power, so my highest power is 4. My leading coefficient is the number in front of my first term, so the term with the highest power, so my leading coefficient is equal to negative 2. Looking at my degree is 4. That is an even number. My leading coefficient is negative 2. That's a negative number. So the end behavior for an even negative, both my arrows are going down. So looking at my first graph, both the arrows are going up. Second graph, first arrow is going down, second one's going up. The third one, we're going up, then down. Last one, both of them are going down. So the last graph is the one that matches the end behavior of the polynomial. So that will be the graph for our polynomial here. There is one more problem. There's a try it problem. There's a try it problem at the bottom for you to do. C, where h of x equals x cubed minus 2x squared minus 4x minus 6. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So this guy's already in standard form. So my degree is 3. My leading coefficient, there's no number in front. When there's no number in front, that means it's going to be 1. So my leading coefficient is 1. My degree 3 is odd, and my leading coefficient is positive. So if I have an odd positive, that means my first arrow will go down, second arrow will go up. And the graph that matches is going to be this first graph. So now we're going to go ahead and look at example 2 on the back. For example 2, this time we are going to identify equations using end behavior. So we are going to use the degree and leading coefficient of the polynomial to determine the end behavior of the graph. We will find the polynomial function that matches the graph. Okay, so we have to figure out which one correctly matches the graph based on the degree and leading coefficient. So for A, if I look at my end behavior, my first arrow is going up, second arrow is going down. So if my first arrow is going up, second arrow goes down, that means I have an odd function because they're opposite directions, and it is going to have a negative, well, let me do that in a different color, negative leading coefficient. So again, odd is going to be the degree. Negative refers to that leading coefficient. So I need to look at my equations below. I need to find an odd degree. So odd degree, 3 in the first one, 3 in the second one. The second two squared, x to the second power, that's even, so no good. And then now I need a negative leading coefficient. Negative leading coefficient would be -3. So the equation that has both that odd degree and negative leading coefficient is going to be my second equation. So the second equation matches the graph. F of x equals -3x to the third plus 10x minus 1. So now we're going to go ahead and look at B. For B, my end behavior, both my arrows are pointing upwards. So if they're both pointing in the same direction, that means I'm going to have an even degree. And since they're both pointing upwards, that means it's going to be a positive leading coefficient. So first I'm going to go look at my equation, look for an even degree. The first equation, x to the fourth, and the last equation, x to the fourth, have an even degree. X to the fifth is not even. And then I need a positive leading coefficient. So 1/2 and the last two are both positive. -2 and -2 and the first two are not positive. Those are negative. So the equation that matches both the degree and leading coefficient is our last equation. G of x equals 1/2 x to the fourth minus 20x plus 1. There is a try it problem C for you to do. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. My end behaviors for this graph are both pointing down. Since they are both pointing in the same direction, it is going to be an even degree. And they're both pointing down. Down means it's going to be a negative leading coefficient. So even degree, the second equation has x to the 6th, the last equation has x to the 6th. 5 is not even, 7 is not even. And then a negative leading coefficient, my second equation has a coefficient of -1. That third equation also has a coefficient of -1. The equation that has both the correct degree and leading coefficient is the second one. H of x equals -x to the 6th minus 10x to the third plus x squared minus 3.